Hey everyone, for the last video of this week's lectures, I want to talk a little bit about what government interventions are thought to do within this perfect competition framework. Or in particular, this is very much what you would consider the classical economics. So your old school, Adam Smith, you don't want government being involved in that's what this is. These are the old style. If we have a perfectly competitive market and all of these assumptions are true, what do we think governments can do that the market can't? Now, the two old ways that governments intervene are going to be either the price floor or the price ceiling. Now, price floors are where governments mandate the lowest price a good or service can be sold for. So there's a minimum price. The best example here would be from the labor market. So your minimum wage is a price floor. You are supplying labor onto the market and companies are paying you, they are the customer, they are paying you for your labor. And what a minimum wage says is, the government is imposing the minimum price an hour of work can be sold for. Now, a price floor below equilibrium prices doesn't do anything. If the minimum price, take your minimum wage. If the minimum wage was 50 cents an hour, doesn't matter. No one's paying that. You wouldn't work for 50 cents an hour anyway. So that minimum wage has no effect on the market because it's below what the market would be paying anyway. But if you started saying, the minimum wage is now $50 an hour, that is above what the market is paying anyway. And if you set a price floor above the market equilibrium, that's going to lead to something called a surplus. So let's look at this graph. We have supply and we have demand. If we let the market on its own, what we would see is, where is supply intersecting demand? The price would be $6 and the quantity supplied would be 4. So basically you can think of it as 4 customers are getting serviced and it's costing $6 each. But what if we impose a price floor of $9? So the minimum price that can be charged is $9. Well, that looks like something up here. We take $9, we go to the demand curve. Down here, we have the quantity demanded when the price is $9. Well, when the price is 9, only one person wants to buy. But if we take this $9 over to the supply, 6 units are being produced. Because when you say the price is now $9 as a minimum, lots of people want to sell at $9. The quantity supplied is going to be very high. But no one wants to buy at a price of $9. So the quantity demanded will be very low. Thus, there's an excess supply of 5 units here. 6 units supplied, 1 units demanded. There's a surplus of 5 units. Firms are overproducing because they're seeing this price of $9 and saying, I want to sell for this price of $9, but you can't force people to buy at that price. So what this ends up resulting in is we're going from 4 people getting this good to 1. 6 units are being produced, but no one wants to pay $9 for them. Only this first person does. Price ceilings are the same basic idea. It's setting the maximum price, though. What is the maximum that can be charged for a good or a service? So rent controls, anti-gouging laws, medicine price controls, etc. If you set the maximum price above the market price, nothing happens. If you say the maximum you can charge for a bottle of water is $100, no one cares. No one's paying that price anyway. But if you say the maximum price you can charge for something for a bottle of water is 5 cents, well, that matters, right? Now we've set the price below the market price. That's going to lead to a shortage. So if we go back to this graph, again, if the market worked the way it would want to, 4 people would buy and they'd pay $6 each. But then we impose a price ceiling of $3. So we go $3, go over to the supply curve and go down. What we find is the quantity supplied at this price is only 2. Because firms are looking at this and saying, I can only charge $3. I can't make money doing that. So only a few very efficient firms decide to charge or provide at that low price. But if we take this $3 over to the demand curve and come down, people are seeing, oh, at a price of $3, I really want this good. So what that ends up causing is 7 people want to buy, only 2 units are being produced, so there's an excess demand. There's an excess demand or a shortage of 5 units. So what this ends up causing again is, if we left it alone, 4 people would be able to buy this good, but because of this price ceiling, only 2 can, even though a lot of people would want to buy at this price. This is the kind of the basic thesis of, in these perfectly competitive markets, government interventions don't really work. We can talk about it a little bit, especially when we talk about people with pricing power or market power. In a market, prices have very important functions. The price of a good tells you how rare it is, how scarce it is. When the price of a good goes up in the supermarket, without even needing to look at the news, you see oranges in the supermarket. It's like $2 a pound. Next week you come back, it's $5 a pound. You know something has happened without needing any other information that has affected either the supply or the demand of oranges such that the price has gone up. Gas prices. Even if you didn't look at the news at all, you would notice gas prices are going way up. So you can intuit from that something in the world has occurred that has caused either the supply or the demand of gasoline to change such that prices have gone up. When you start messing with prices, though, when you try to intervene into a market, that ability of prices to inform consumers and producers, because everyone can see these prices, everyone knows, hey, prices of oranges are going up, maybe I should start growing oranges. Gas prices are going up. Maybe we should reopen those oil fields out in the Midwest, right? If you start intervening into these markets, though, these price signals lose their actual information power. And so it's very disruptive, and in this perfect competition kind of a model, not a good idea for governments to intervene. Anything that shifts the prices one way or the other is going to be ultimately disruptive in a negative way. All right. Now here's just an example from the homework to talk about how to read this. So mathematically, you may see something like this, where the cost is 0.002 q raised to the power of 3, plus 22q plus 750. Here's the way to read this. There's a fixed cost of $750. This cost is not associated with the quantity that you produce, and so therefore, this is your fixed costs. Your variable costs are going to be anything that changes with your output Q. In this case, it's not linear. Every unit you produce costs 22 plus some exponential factor where the more you produce, the more expensive it becomes to produce the next one. This marginal cost is that. What does it cost to produce the next one? This is a derivative. This comes from calculus. I'm never going to ask you to take this derivative, but it's the same basic idea. The cost of producing each unit is 22 plus something that depends on the amount you've already produced. The larger Q, so the more you've already produced, the more expensive it's going to be to produce the next one. That's what this Q squared is telling you. This Q and the marginal cost, every unit you make is going to cost more and more the more of it you've already produced. In other words, you can't just expand production forever. The costs are eventually going to overwhelm you. Revenue might look like something here. 80 times the quantity you produce. What this would tell you is marginal revenue is $80. Every unit Q that you sell increases your revenue by 80. This is the same thing as saying you're charging $80 times the quantity that you produce. So to maximize your profits here, you would set your marginal revenue equal to your marginal cost and solve for Q. Well, marginal cost is here, and your marginal revenue is just 80. It's just this number here. It's the amount your revenue goes up for every unit you sell. So, we set marginal cost equal to marginal revenue, 0.006 Q squared plus 22 equals 80. Well, subtract 22 from both sides. 0.006 Q squared equals 58. Well, divide both sides by 0.006. Q squared equals 9,666.67. I rounded it off here. Take the square root of both sides, so just doing some algebra, and the profit maximizing output is 98.31. Now, this may seem very theoretical, like, oh, these equations that you're just putting together, you wouldn't ever actually solve these. But this is the thing. If you know how much money you're spending to produce your goods, and you know how much you're producing, you can derive these cost functions for your firm. You can actually go in, dig through the data, and make your cost function as a function of output, calculate your marginal cost. You know the price that you're selling for. You can actually do this, and firms do. They may not give you an exact number. It may not give you, we need to target exactly this, but it's very good for giving you a baseline of, we should be operating about here based on our costs in the aggregate and our revenue. I mean, firms actually do this. This is where output targets come from, is this sort of analysis. And profit maximization is always going to be when your marginal revenue for the last unit produced equals the marginal cost. Produce every unit that's actually profitable to produce. And where that number is going to come from, especially for your marginal revenue is just going to be the market price. So if you can see the price that the market is giving you, which surely you can, you need to know the price you're charging. You can look at how much you're spending. You can look at the costs, like the outflows of your company. You have to know what that number is. And you can know how much that cost changes based on your output. You know, your output varies over time. You can build all of these from information available to firms. And they do. And this is where your basic output targets will come from, is exactly this kind of analysis based on your costs and the prices that you can receive in order to maximize the profit of your firm. It's not comprehensive, but this is very much where the baseline starts, is these sort of simple cost-revenue associations. So this is not purely theoretical. There is practicality to these kinds of equations. Even if you don't yourself solve them or dig into the data, it is important to know this is possible. It's probably what techs or statisticians that you work with are doing. They're using something about your own firm's data in order to produce these kinds of output targets or cost projections or profit estimates, it's all coming from this same basic idea. How much does it cost to produce each unit? How much money are we receiving for each unit? And by looking at that, we can just determine, well then, to maximize our profits, we should be about here for our output.